Hello, everybody. This is the start of our first lesson, covert operation DING. Okay, and this is the first lesson. Okay, now let's start with the first question. Solve. You're asked to solve this equation. Okay, solve means to find the unknown, and in this particular question, you see that the unknown is x. Okay, which is at the index. Okay, there's another x here. Then you have 3 to the power of x minus half minus 2 to the power of 2x minus 1 equals to 0. Now, how do we solve this question? If you have not tried, right, you should try. Or if you not normally, right, I will send you the so-called worksheet, the questions first. You can try. Then after that, you cannot do. You just watch this video. Okay, but you can pause the video at any point in time and try and figure out what's the next step. Okay, before I show you, that will help you to become a better thinker. Okay, instead of just letting me spoon feed you. All right. So now, how do you think we can solve this question? The problem now is that both the bases are different. Okay, and not only are the bases different, this is a minus sign. Okay, so if the two bases are the same, and then this is like a multiplication or division, then you can still do something and work things out, right? But right now, the two bases are different. Okay, so the logical thing you can do now is to probably split them. Okay, you add 2 to the power of 2x minus 1 to both sides of the equation. Okay, so this will end up here, and then you split it up. Why split it up? Because the base are currently different. Okay, so you are not able to so-called compare the power of this and power of this and then equate the two powers. Cannot, because the two bases are different. So what we're trying to do now is we are trying to make the index or the power of this base 3 and the power of this base 2 to be the same. Okay, so right now you see there's a power x here, but there's a power 2x here. So what can we do to make them the same? Okay, you raise these 2 to power 2, that will be 4 to the power x. That would make these two have the same power. Okay, and when you have the same power, right, you can raise this 3 over 4 to the power of x. Yeah, and then after that, this side here, you can also change it to base 3 over 4, and then you can equate the power. Then you will get x to the power of half. Okay, so this question it's not say very difficult, but it is tough because you have to know that you are not able to equate the power because the base are the different. Okay, so you have to work it out using this method. Okay, and if your manipulation of indices is not strong, you won't be able to get this answer. Okay, now there is another way to solve this question, and that other way requires knowledge of logarithms. Okay, so by right you're supposed to learn logarithms this year, but because of COVID-19, so we skip, right? Okay, so let's see how you can do it using logarithms. Now, if you're asked to solve this, okay, what you can do is again add 2 to the power of 2x minus 1 to both sides of the equation, and you end up with this. You end up with this, this without the log yet. Then you take log on both sides of the equation. Okay, so you log the left hand side, then you log the right hand side. When I write LG, it means log to the base 10. Okay, why do I want to use log to the base 10? You will see on your calculator, right? This key here, this log is log to the base 10. So it's something that you can calculate using the calculator if your base is 10. This number here is the base. Okay, and the short form is LG or simply log as you see on the calculator. Alright, now later I will teach you logarithms, but right now you just need to know that the number here is what we call the base. Okay, and the short form of log base 10 log to base 10 is LG or log. Okay, so that's all you need to know for now. Okay, so I can take log on both sides, meaning after this step, right, where I add to the power of 2x minus 1 on both sides of the equation, then I'll end up with this, right? Then I take log on both sides. So it's log this one, log this one. Okay, whatever I do on the left, I do on the right. So nothing, no big deal. This is, you've been doing this since sec 1. Okay, now after this, what do we do? Now there is, in logarithms, there is this law called the power law. The power law says that, let's say I have log of whatever base 2, then to log of 4 to base 2, and then there is a power of 3 here, right? Okay, I can actually bring this power right down to the front here. That means this whole thing is equivalent to this. Later I'll prove it to you, okay? I just want you to know how to apply this, okay, to this question. Very simple one. I give you an example. Let's say I have log x, then log of y to base x. Okay, this to the power of, let's say, p. This power, right, I can actually put it right in front of the log. Okay, everything else remains the same. I just bring this power down to the front. That's all. So you must know this, what we call the power rule. Okay, now look here. I can apply the power rule here because this x to the power of this 3 to the power of x minus half, right? I can actually bring it down, and this this power 2x minus 1, I can also bring it down to the front, meaning like that. Okay, take note, is this whole thing that I'm bringing down, and is this whole thing that I'm bringing down. That's why I need to put brackets. Okay, now this log 3, if you were to press your calculator, it's just a number. So you see, log 3, I press the calculator, it's just a number. Similarly for log 2, it's just a number. Okay, so you can now think of this as a number, and then this number, right, you can multiply in. Okay, it's like opening up the brackets, and then this is also a number. You multiply in, and what you get is this x times log 3, right? Then minus half log 3. Okay, minus half times log 3, it's just minus half times another number. So this whole thing is just a number. Okay, then 2x times log 2 is 2x log 2. Minus 1 times log 2 is just minus log 2 lah. Okay, then now what do you do? Same as what you've done in your sec 1. Okay, group all the x together. That means make x the subject. So I group all the x together. Okay, then make x the subject. Then when you press calculator, right, you will get this. Okay, now some of you may find this method very difficult. Alright, you may think that, oh, actually this is easier. Alright, but you will find that next time when you go to sec 4, actually by right you should learn this in sec 3. We skipped it. So you will find that for certain questions, right, you have no choice but to use this method. Okay, you will not be able to use this method. This question is designed such that you can use this method for comparison, okay? But if we tweak the question a bit such that you are unable to make the 2 base to be 3 over 4, right? You will have no choice but to use this method, and we will definitely make you use this method next year, okay? So you have to learn it now, okay? Now, I'm going now to, I'm going to skip the second question first. I'm going to go now to simple concept of logarithms, okay? Now, logarithms is a very powerful concept. Okay, so logarithms are logarithms. Okay, you will find that my pace of teaching will be very slow this holiday because it's holiday lah. Huh? Okay. Yeah, so we will go slow. Okay, now, you remember in index form, 2 to the power of 3, right? Means 2 times 2 times 2, 3 times. The answer is 8, right? There's another way to write this or to express this, and we call it the logarithmic form. Okay, logarithmic is like English word, different form of logarithms. Logarithms is like the whole thing, but this logarithmic is just an English form of this kind of terms. Okay, so how do I interpret this, whatever I've written here? Now, first of all, I tell you how we read this first. This is log or logarithm of 8 to base 2, okay, is equals to 3. So when I give you this, it is logarithm of 8, okay, to base 2 is equals to 3. Now logarithm, right, the answer is actually the index. Okay, remember when you learn index form, this number here, the power, right, is actually the index, right? Okay, and then this is your base. Whereas for logarithmic form, this number that you put right at the bottom here, right, okay, is the base. Okay, so I think some of you will be able to see that the way to transform this into this is base to the power of 3 is equals to 8. Can you all see that? Okay, so 2 to the power of 3 is 8. Then 2 to the power of 3 is 8. So the way we write this index form in logarithmic form, right, is like that. 2 to the power base 2 to the power of 3, which is the index, is equals to 8. So the argument, remember argument, we learned this word argument when we did trigo. The argument, right, is the answer for 2 to the power of 3 lah. Okay, okay, now let's do another example, just to get you familiarized with this, okay? Now, 2 to the power of 5, we know is 32, right? Now, how do I write it in logarithmic form? So you write log, the argument will be the answer lah. Log of 32 to base 2 is equals to 5. This equals to 5 is the index. That means this logarithm, the answer is the index. Okay? So another way to interpret it is 2 to the power of what is equals to 32? The answer is 5. Okay? Now, I hope you can try to get the hang of it. Now, how about this? If I want to write this in logarithmic form, right, it will be log of this this answer. Okay, so it's the argument. So log of 49 to base 7, this is the base, right, is equals to 2. Yeah, because when you log, when we talk about log, right, the answer is actually the index. Okay, so log 49, log of 49 to base 7 is equals to 2. That means, what you can think of it this way, it's easier to think of it this in this cyclic form. 7 to the power of what is 49? Answer is 2. Okay, so let's do a few more. Okay, so 10 to the power of 3 is 1000. So log log of this answer, log of 1000 to base, this is the base, right? To base 10 is equals to 3. So 10 to the power of 3 is 1000. Okay? Yeah, that's all the example I have for you. So I hope you are able to transform from index form to logarithmic form and vice versa. Okay? You need to know how to do that. So this is the first skill you need for logarithms. Okay? Now let's move on to some more reinforcement. Okay, if I ask you to evaluate, they won't ask you to do that, but it will be like part of your working in a certain question. Okay, you will know what I mean when we come to that. So let's say I ask you to evaluate this. Now, what do I mean? We know, right, log of a number, okay, to a certain base, is actually asking you what is the power or what's the index. So what 2 to the power of what is equals to 16? 2 to the power of what is equals to 16? So the answer must be, oh, I never give answer. Okay, 2 to the power of what equals 16? Answer 4, finish. Okay, now we do the next one. Wow, I leave so much space. Okay, I leave so much space just to tell you, if you don't know, right, you let the answer be x. Then 2 to the power of x is 16. So what must this x be? Then you, correct? So x equals to 4, but no need it's so easy, right? Okay, but for a difficult question, you will have to do it this way. Okay, now let's do the second one. Maybe this one you need already. Okay, so 2 to the power of what is 1 over 16? Okay, so we do it. We let log 2 like that equals to x. You let it with y or z or whatever you want also can. So this means 2 to the power of x is equals to 1 over 16, right? Okay, and then you change this to base 2. It's not base 2 yet. This whole thing, yeah, like that. Like that, then x equals to minus 4. Okay, so what it means is 2 to the power of minus 4 is 1 over 16. Okay, some of you may be able to see it immediately. In fact, you should be able to. If you can't, then you have to train yourself to be able to. Okay, wait, I adjust my, why no battery? Okay, you look at the next question. I look at it. You try the next question. I'll try the next two. I adjust my phone. It's